Okay, this next problem has very specific directions. Okay, use the limit definition of derivative, and then I remind you that it is given by the limit as h goes to 0 of f of x plus h minus f of x over h. To show that the derivative of f of x equals 1 minus 4x squared is f prime of x equals negative 8x. So notice I'm not asking just to find the derivative of this function. If I was, you could use your quick derivative rules and very fast find a solution of negative 8x. Instead, I am asking you to use the limit definition of derivative. This is sometimes also simply worded, excuse me, use the limit definition. So if you see, as soon as you see definition together with either limit or derivative, then you know you need to use the equation that we see given here. Excuse me. Okay, so here's our limit definition. If you don't have this memorized, you're going to want to write this on your note card in case you have a similar type question on your exam. You're also going to want to, like I said, pay very close attention to the directions, because if it tells you to use the limit definition and you don't, you're not going to get credit for the problem. Okay, so let's start by actually writing down this limit definition. So we have the limit as h goes to 0 of f of x plus h minus f of x all over h. Now notice how I'm going to write the limit each time until I plug in the value h equals 0. Now if I tried to plug in h equals 0 right now, I would end up with f of x minus f of x over 0. And that's just 0 over 0, which is indeterminate. So instead, I have to do what the definition tells me to do. And it tells me to first find f of x plus h. That means I'm going to take my function and I'm going to replace the x with the quantity x plus h. So I'll have 1 minus 4 times, instead of x, I'm going to have x plus h all squared. Then I have to subtract the original function, subtract f of x. Well, f of x is 1 minus 4x squared, and all of that is divided by h. And I already committed a sin in mathematics. Let's go ahead and fix it. I need to write the limit out in front. Oh dear. Okay, so what does this become? Well, this is going to be the limit as h goes to 0. Now, in my first term, the 1 stays, the negative 4 stays, but now I'm going to square out x plus h. If I square x plus h, I'll get x squared plus 2xh plus h squared. And then I still have my minus 1 minus 4x squared. And that's all over h. Okay, next step. Next step is going to be distributing. In the beginning, I have to distribute not just the 4, but the negative 4 to my 3 terms in parentheses. And at the end, I have to distribute the negative to the 2 terms in parentheses. So what happens when I do that? Well, I still have the limit as h goes to 0. I'll have 1 minus 4x squared minus 8xh minus 4h squared minus 1 plus 4x squared all over h. Okay, now we get to the fun part. This is the simplifying part. And if you've done it correctly, everything that doesn't have an h in it will end up canceling. So I have a plus 1 and a minus 1. Those cancel. I have a negative 4x squared and a positive 4x squared. Those cancel. So I have the limit as h goes to 0 of negative 8xh, minus 4h squared all over h. Now, you'll see that if I plug in 0 for h right now, I'm still going to get 0 over 0, which is indeterminate. However, since I have every single term has an h in it, I can factor an h out of the numerator and cancel it with the denominator. If I factor the h out of the numerator, I'm going to be left with negative 8x minus 4h all over h. And now my h's cancel, and that's going to leave me with the limit as h goes to 0 of negative 8x minus 4h. So what happens if I plug in 0 now? Well, now if I plug in 0 for h, I don't have to write the limit anymore, and I'll get negative 8x minus 4 times 0, and that will, of course, give me negative 8x. And what is all of this? This was the limit definition for the derivative of my function. So all of this tells me that my derivative, f prime of x, is going to be equal to negative 8.